Hi, I am Krishidhar, studied in Shankara Institute of Technology. I am explain about topic is distributed database systems. Transparencies in the DDBS. Transparency, it refers to a separation of the high-level semantics of systems from low-level implementation issues in the distributed system. It hides in the implementation details from the users of system. The user believes that she is worked with the centralized database systems and that all the complexities of the distributed database systems are either hidden or transparent to the user. Four main categories of transparencies: distributed transparency, transaction transparency, performance transparency, DBMS transparency. Transparencies in DBMS, distributed transparency. Distributed transparency refers to the degree or extent to the which details of fragmentations, replications, and locations are hidden from the user. Distributed distribution transparency can be classified into fragmentation transparency, location transparency, replication transparency, local mapping transparency, naming transparency. Fragmentation transparency, it hides to the fact from the users that the data are fragmented. User too are not required to know how to relation has been fragmented to retrieve data. The user need not to specify into the particular fragmentation names. Location transparency, user are not required to know the physical location of the data to retrieve data from the distributed database. With the location transparency, the user has to specify the database fragment names but need not to be specified into the fragment are located in the system. Replication transparency, the user is unaware of the fact that a fragment of relation or replication and store in different sites of the system. Local mapping, it refers to the fact that a user will be aware of both the fragmentation names and the location of fragments, taking into account that any replication of the fragment may exist. In this case, the user has to mention that fragment names and the location of the data access. Naming transparency, in a distributed database system, each database object which has relations, fragments, replicants, etc., must have unique names. Therefore, the DDBS must ensure that two sites created a database objects with the same name. One solution the problem to create a central name server which has the responsibility to ensure uniqueness of the all names in the system. Naming transparency means that the user not aware of the actual name of the database object in the system. In this case, the user will be specify the alliance names of these database objects for the cross accessing. Transaction transparency, this ensures that a distributed transaction maintain database integrity and consistency. Each transaction is divided into sub-transactions. Each subtraction can be updated data stored in a different size. Transaction transparency ensures that the distributed transaction will be successfully completed only if all sub-transactions are completed successfully. Performance transparency. Performance transparency required a DDBS to perform as it if it is aware of centralized DBMS. The system should not suffer from any performance degradation due to the distributed architecture. DBMS transparency. This is also known as a heterogeneity transparency. DBMS transparency hides the knowledge that the local DBMS may different, only applicable to heterogeneous DBMS. This allows the integration of several local DBMS under a common global schema. It is one of the most difficult transparency to provide as a generalization. Transactions, to understand the consisting of set of operations, a single logical unit of work database systems and moves data from consisting states to another. It may be entire program or the part of the program. Asset properties of transaction. A means atomicity, C means consistency, I means isolation, D means durability. Acid properties of transaction. Atomicity. All changes to the data are performed as there are single operation, that all of the changes are performed or none of them are. Consistency. A transaction must transfer the database from the consistent state to another consistent state. It can ensure consistency by enforcing the all constraints specified the database schemas. Isolations. Transaction can execute independently, they are not depending on each other. In other words, transactions are isolated from one another, and to partial effect in completed transactions should be not visible to other transactions. Durability. It refers to the fact that the effect of successfully completed transactions are permanently recorded in the database and will not be affected by the failure. This is ensure that once the transaction commits, the changes are attributable to cannot be erased from the database.